Just like turning a sum into a product can be useful, turning a product into a sum can also be useful. So we're going to answer the question sine alpha times cosine beta. Is there a way to rewrite this product as a sum of sines and cosines? I'm going to look at the formulas that I have, the sum and difference identities, and notice that there is a sine alpha cosine beta in the first one, and there's also a sine alpha cosine beta term in the second one. So if I combine the first two equations here, I may be able to create a third equation that could represent sine alpha cosine beta in a different manner. Take these two equations and we are going to add them together, right? We do not want to get rid of sine alpha cosine beta, so we'll add them together. Sine alpha plus beta plus sine alpha minus beta equals sine alpha cosine beta plus sine alpha cosine beta. So there are two of those. And positive cosine alpha sine beta plus a negative is simply 0. All right, now we have a third equation. Here I see sine alpha cosine beta, which is what we're trying to come up with a shortcut for. So let's divide both sides by 2. Let's get sine alpha cosine beta by itself. Sine alpha cosine beta can be rewritten as sine quantity alpha plus beta plus sine quantity alpha minus beta all over 2. Remember that dividing by 2 is the same as multiplying by 1/2. So you can write this formula as a fraction all over 2, or you could write this as a quantity for which you're multiplying 1/2. 1/2 times this quantity. So this is an acceptable way of writing the formula, and this is also an acceptable way of writing the formula for how to change the product sine alpha cosine beta into a form where you are adding or subtracting instead of taking the product. If you do some more algebra, you can find the rest of the identities, and here they are, our product to sum identities. How to turn the product of sines and cosines into a sum, or a difference of sines and cosines. Our first example is sine 2x times sine 10x. Which formula involves sine times sine? That would be this one. Assign alpha and beta, so I'm going to call the first angle alpha and the second angle beta. Here's the formula we're going to use. We've assigned our alpha and our beta, so go ahead and plug it in now. You have 1/2 times this quantity, cosine of the angle alpha minus beta, so 2x minus 10x, minus cosine of the sum of alpha and beta, 2x plus 10x. The rest is just algebraic simplification. 1/2 times the cosine of 2x minus 10x is negative 8x, minus The cosine of 2x plus 10x is 12x. The directions asked us to leave our answers in only positive arguments. Because cosine is an even function, cosine of a negative input is the same as cosine of that input being positive. 1/2 times cosine of positive 8x minus cosine of 12x. In the answer key, they write it as one huge fraction, so this is what it will look like. Cosine 8x and cosine 12x are not like terms. You cannot combine them. So your answer for turning this product, sine 2x times sine 10x, into a sum, either one of these forms is acceptable. You can have parentheses around the argument. You don't need to necessarily. And our final example is -3 times cosine 3a cosine a. Okay, none of our formulas have some number in the front of the product. So this -3 that's multiplied to the front, we need to take that and just kind of put it off to the side. Okay, so -3 is being multiplied by this product. -3 times cosine 3a times cosine a. So when you expand cosine 3a times cosine a, or turn it into a sum or a difference, then you will end up multiplying the -3 by that entire sum or difference at the end. The formula for a product of cosines is right here. Go ahead and assign an alpha and a beta. I will call alpha 3a and beta a. -3 times (1/2) cosine alpha plus beta 3a plus a plus cosine alpha minus beta 3a minus a. Do the algebra to simplify. So -3 times 1/2 is the same as -3/1 times 1/2, which is -3/2. That's being multiplied by cosine of 3a plus a is 4a. Again, you can write parentheses around this, or you don't have to. Plus 3a minus a, that would be cosine 2a. This is an acceptable answer. You could also write it as an entire fraction. Let's go ahead and distribute this. So you would have -3 times cosine 4a over 2 plus, I guess it's -3, so minus 3 cosine 2a over 2, right? You could imagine these are over 1. And the answer key writes it as one fraction, so combine these two. -3 cosine 4a minus 3 cosine 2a all over 2. So you have an acceptable answer here, and you have an acceptable answer here.